You watched a video on the central limit theorem, and I want to recap that really quick. So suppose we have a simple random sample of size n from any population, and it has a mean of mu and a standard deviation of sigma. So the central limit theorem says when n is really big, the sampling distribution of x bar is approximately normal. So in other words, x bar is normally distributed with a mean of mu and a standard deviation of sigma over the square root of n. So there are two parts to the central limit theorem. So the first part is if your original distribution is normal, then your sampling distribution is also going to be normal. It doesn't matter what your sample size is. If your initial distribution is not normal, and especially if it's skewed or something of that sort, then you need to make sure that your sample size is large enough. And by large enough, we mean 30. So 30 is a large size in statistics, which is kind of a funny thing to think about. All right, so we have some pictures to look at that. If I could get this to advance here. So we have three distributions across the top here, and they have various sampling distributions. So that second row is a sample size of 2. So we have sampling distributions of size 2, sampling distributions of size 10. So they're starting to look a little more normal. And then you can see by the time that bottom row we get to a sample size of 30, those sampling distributions are all starting to look pretty normal. Okay, so by the time we reach a sample size of 30, that central limit theorem kicks in, and we're good to call our sampling distribution normally distributed, which is great because it allows us to use all of those probabilities that we learned how to do in chapter 3. So let's go ahead and take a look at that on the bottom of page 2 on your classwork. Okay, so number 7, express courier services found that the delivery time for packages is normally distributed with a mean mu of 14 and a standard deviation sigma of 2 hours. For a package selected at random, what is the distribution? Okay, so we're looking at a sample size of 1, so n equals 1 here. And because the initial distribution is normal, we can stick with normal. So we have a normal, our mean is 14. And our standard deviation is 2 divided by the square root of 1, which just stays 2. So we're normal, 14, 2. All right, and we're looking for a package selected random. What is the probability that will be delivered in 15 hours or less? Okay. All right, so we're going to use our Rossmann chance normal probability calculator that we used in chapter 3. So you can just Google Rossmann chance normal probability calculator. And there it is. Okay, so we'll put in our 14 for our mean and our standard deviation of 2 and click scale to fit. Okay, and then we'll click this first box line here, and we're looking for the probability that a package will be delivered in 15 hours or less. So that X is the value I'm interested in, the 15. So I'll put a 15 there and hit enter. And then you'll notice the blue part here, that's going to give me the probability for the part that's shaded in blue. And I want 15 hours or less, which is what's shaded in blue. So my probability is 0.6915 or 69.15%. Okay, so that gives us our first probability. Okay, so I went ahead and wrote down that probability here. And then part 3 says if a simple random sample of 16 packages is selected, what is the sampling distribution of their mean delivery time? All right, so it's going to be normal, 14, 2 divided by the square root of 16. Okay, so that's going to be our sampling distribution. I'm going to go ahead and simplify that because I do need to be able to put that into our probability calculator. So I get normal, 14, 0.5. And that'll be my new distribution. And for part 4, we're going to use that distribution, and we're still interested in the same probability, except for now we're looking at the average length for all 16 packages. So if we take those 16 packages delivery time and we average them, what's the probability that that average time will be 15 hours or less? So if you look at these, really the only thing that's changed here is my standard deviation. I'm still interested in the 15 hours. I still have a normal distribution. My mean is still 14. So the only thing I really need to change is my standard deviation when I go back to our normal probability calculator. So let's go ahead and head back there. So here we are back at our probability calculator, and everything's still here that was here before. So I still have my mean of 14. Now I'll change my standard deviation to be 0.5, and I'll click Scale to Fit. I still have 15 or less marked here, so I don't need to change that. And now my new probability is 0.9772, okay, or 97.72%. Right? So that gives us our answer to part 4. All right, I hope that makes sense, but we have 2 more pages of practice on this, and so hopefully you'll get the hang of that. But if you don't, feel free to send me an email or stop by for office hours over Zoom.